Hello friends, welcome to another tutorial in digital image processing. In today's tutorial, we'll talk about filters, which are also known as kernels at times in image processing, and we'll also talk about convolution in image processing. Please understand filters are certain matrices in image processing that will perform certain operation on an image. For example, if I have this image of, let us say, size 6 by 6, so each of these boxes, they represent 1 pixel, and the value inside the box represents the intensity of a pixel. And as and when images grow bigger in size or they become colored, they'll have 3 values in each box representing RGB components, and they'll be huge in size, like 1000 by 1000, or bigger images. But for the sake of simplicity, we're taking up just one value inside each pixel. So this could be a monochrome image, and this value could represent its grayscale image. Anyhow, if this image was to be processed, it could be processed in a lot of ways. For example, we could sharpen this image, we could find a vertical edge in this image, we could find a horizontal edge in this image, or we could blur this image, etc. So in order to perform all these operations, you would require yet another filter, which is nothing but a matrix that would perform some mathematical operation on this image and will give us a desired result. For example, this 3 by 3 matrix, if it is convolved with this image, will give us sharpening effect. And similarly, we have this matrix. If you look at this matrix, this is 1 1 1 in the top line and minus 1 1 1 in the bottom line. This is an example of a horizontal edge detector filter. So you can see a filter or a kernel is nothing but a matrix, and this is usually convolved with the image to get the desired result. We can have another filter. This is another filter, and you could guess by now that this is a vertical edge detector. So you'll find many filters with different values in them, and those values are put into those filters in such a way that they will give us the desired output when convolved with the image. Now, once we understand that this kernel or this filter is a small matrix, then how do we go about doing convolution of this matrix with the image? Now, this is what I'm going to explain in this video. In order to do convolution, and at times this is also known as cross correlation. Please understand, convolution is a misnomer while we study the process of finding the pixel values in the resultant image. Now we'll talk about the process which is involved in finding the pixel value of the resultant image. Please understand, convolution is a misnomer in this context. The actual thing which is happening is cross correlation, because mathematically convolution means that if you have a matrix, let us say 3 by 3, and you want to do convolution of this matrix, you would need to flip this matrix twice before actually performing the operation that I'm going to describe. But I'll not go into the details of that. We'll loosely call this as the process of finding the pixel value of the resultant image. we need to start the process by placing the filter matrix on top of the image, starting from the left hand top corner, and the resultant matrix that we'll obtain will be a 4 by 4 matrix. And the reason for that is the resultant, if this image file is an n by n matrix and this filter is an f by f matrix, the resultant matrix will be n minus f plus 1 into n minus f plus 1 matrix. So in this case it will be 6 minus 3 plus 1, which is 4 by 4 matrix. So this is the formula. Once we have placed this filter matrix on top of the image in such a way, we simply need to multiply the value of the pixel with the value of the filter. So this is going to be 3 into 1, and we're going to add all these values: 3 into 1, 1 into 1, plus 2 into 1, then 0 plus 0 plus 0, then a minus 1, minus 8, minus 2. So this will give me 3 plus 1 plus 2, minus 1, minus 8, minus 2. So this will give me a minus 5 value here, and whatever you get after adding the products of these pixels, we'll put it in this box on the top. Now, in order to get the value of the next box or the next pixel, we simply slide this by one position like this, and we do the process again. We do 0 plus 5 plus 7 plus 0 plus 0 plus 0, minus 2, minus 9, minus 5, and whatever the value that we get. So this is gone. This 7 gives me minus 2 here. So this gives me minus 4, and so on and so forth. You can simply keep on sliding this filter to get the pixel value at the output, and this is our output. And because you can no longer slide this filter after this position, so that is why we get a 4 by 4 matrix at the output. However, this pixel at the output would contain the information from all these pixels, so the information is not lost, kind of a thing, but the values of the edges are thrown away from the actual image and they are condensed into a smaller image, and that is why convolution would always result in reducing the size of the output image. So there is a limit as to how many times you can perform these convolution operations on the images, and then you slide down and then slide right to find the pixel values, and you'll get this output matrix, which will be 4 by 4 in size. So that is how cross correlation, or we can say convolution, occurs. The process is like this. It is actually multiplication of the pixels of the image with the pixels of the filter, adding them up and then substituting them in the topmost left box. So it is pretty simple, but again the process is lengthy. That is how the output is obtained after convolution. And I hope this introduction to the filters and the introduction to the process of convolution was of help, and if you liked the video, give it a thumbs up. I'll take up more details, more types of filters, and we'll take up padding and strided convolutions in the future. And stay tuned. You have a great day ahead. Bye.